kiddos! Today in science, we're going to be watching a couple of videos together, and we're going to be talking about 3 different animals and some of their special senses that other animals might not share. So the first animal we're going to look at is a bat. So I'm going to go ahead and start our video.
This slow-motion video of a bat drinking from a pool of water was made by German scientists Stefan Greif and Björn Siemers. The pair set out to investigate the sensory cues that help animals recognize features in their environment, in this case, the ponds and rivers that bats use for orientation and foraging. We know a lot about how bats use echolocation to target insect-sized objects. But this is the first study to show how they recognize large, flat objects like ponds. Stefan and Björn caught wild bats in Bulgaria and tested them in a large, dark flight room. They presented the bats with either smooth or textured plates, positioned on the flight room's sandy floor. When presented with a smooth plate of metal, the bats treated it like water and tried to drink. Even when the metal plate was put on a table, a very unnatural position for a pond, the researchers watched as the bats attempted to quench their thirst. A smooth metal plate reflects sound in the same way as a body of water, so this behaviour supported the researchers' hypothesis that bats rely on the mirror-like echo-reflection properties of smooth surfaces to recognise water in their environment. When a bat flies above a smooth surface, most of the sound waves in its call are reflected away, but a small proportion hit the surface immediately below and then bounce back, a telltale sign of water if you're a bat. Stefan and Björn also tested young bats that had never encountered a pond or river before. These naive bats also tried to drink from the metal plate. This was the first time in their lives these youngsters had encountered a large, smooth surface, so this suggests that water recognition in bats is hardwired into the brain. And the researchers claim this is the first evidence for innate recognition of a habitat cue, such as a pond, in a mammal.
All right, so that is our first animal. We talked about a bat in this video, and its main sense that we're talking about is echolocation. Can you think of another animal that uses echolocation to find things? I want you to think about that in your brain for a second. It's usually something that swims in the ocean. Hopefully, you thought of the word dolphin, because dolphins also use echolocation. So that is something that's super cool that we as humans cannot do. Our next animal that we are going to talk about is a snake. So hang tight for this video to start.
All warm objects constantly emit heat in the form of infrared radiation. The camera senses this infrared in amazing detail. It means Michael can record the snake's movement in total darkness.
This camera is really useful for us here tonight because it allows us to see basically what the snake is seeing. We are looking through a snake's eyes when we use this infrared sensitive camera.
The goal of this experiment is to see whether the snake can sense a warm object in the pitch black. The target is a black balloon filled with warm water. To the snake, it should look like a warm-blooded mouse or a small rat.
And we'll have that balloon swinging back and forth like a pendulum. The balloon is black, the background is black. We'll actually turn the lights out for you here. So there's no visual contrast. The idea is that there should be no way to see that balloon. The only difference between the balloon and the background should be thermal contrast. The balloon is warm, the background is relatively cool.
Handling a large python in the day requires great care. It's even more difficult in the dark. Michael covers the snake with a box until he's ready to start the experiment.
These snakes have lots of teeth, so if they bite you, you know it.
But for Michael, it's worth the risk. If the experiment works, the footage will be a world first.
So after the lights are off, we'll remove the box from the snake. The snake will be free, and hopefully we'll see some very interesting behavior. We'll learn something new about this amazing, unusual sensory system.
In the pitch black of the swamp at night, conventional vision is useless.
It's really dark. I can barely see to get this box off the snake. I'm afraid it might look like a warm balloon to this snake. Uncover the snake. Good thing we have this infrared camera. Otherwise, I'd have no idea where the snake is.
The sensitive infrared camera picks up the faint heat of the snake as a vivid orange and the warm balloon as a bright white.
Here he comes. Tongue flicking at it, moving his head with it. He definitely sees it. He definitely sees it. He's got eyes, but it is pitch black dark out here. So something else is telling him that that balloon is there. It is absolutely dark. It cannot be using its eyes, but it's following the motion of that balloon. It knows that balloon is there.
All right, so that is something super cool that snakes have. They can see with a thermal vision. So they can see in patterns of heat where things are. So even if it's super dark outside or they live in a really dark place, if something is warm, so a small animal, they can easily track that animal and catch it, which helps them be able to hunt even when it's not daytime. So that is a super cool thing. I want you to think about that in your brain, and I want you to maybe look up after watching this video if you think there's another animal that can do something like that. So the next creature we're looking at isn't necessarily an animal, it's an insect, but we are going to be talking a little bit about the ant in this next video.
This is a carpenter ant. Sniffing. That's how they follow the chemical trails that are laid by fellow ants, or research scientists. Of course, ants don't have noses. Their smelling organs are mostly in their antennae. They have a few on their feet, but that's another story. Smelling is how they navigate the world. It's how they recognize other ants and locate food. It's more important than sight, sound, or even touch. Scientists wanted to find out more about exactly how ants follow a scent. So they painted tiny trails with ant pheromones and added ink so they would be visible. The ants, as expected, could follow various routes, like zigzags, dotted lines, and curves. Sometimes they just wandered off. Researchers analyzed dozens of hours of footage using various computer models that track the ants' body positions and antennae movements. What they found was that ants use their antennae to sweep the trail side to side the way you might use a metal detector. And they weren't one-trick ponies. For ants, They adopted 3 strategies to navigate their environment. First, there was probing. When an ant was still or moving slowly, it kept its antennae close to each other. There was exploratory. Ants took slow, winding paths near a trail with antennae further apart. And when they had the trail down pat, there was trail follow. They moved along the trail accurately, antennae on either side of the path. Interestingly, each ant seemed to have a left-right antenna preference. They kept one closer to the trail. Some were lefties, some were right. And when an antenna was removed, many ants adopted new strategies for navigation, changing their body position and antennae range. They definitely weren't automatons. You might almost say they had personality.
All right, so that is our last video for today that we were going to watch, all about the ant. Hopefully you learned a little bit more about some animal senses today. So the ant uses those antennae to be able to smell a trail, to be able to follow where they should go. So think about all of the senses that you have. We have our hearing, we have our sight, we have our taste, we have our touch. Think about how those are different than some of the animals we learned about today. Make sure that you head to our Google Classroom and you answer the exit ticket for today. You're going to be talking about the different senses that we learned about with each creature. All right, guys, have a great rest of your day and do a fantastic job on your exit ticket.